Good morning everyone, I'm here to tell you about the introduction of cables. In this today I will going to tell you about the crossover cable and straight through cable, because right now we need that right. So I'm going to tell you about these two cables. If you check on the left side, when I'm clicking on this cable, see and device components member, if I'm clicking on connection, we are getting a number of cables. So on what cable we will going to work on today, that is copper straight through and copper crossover. These two cables we did it. So there are different steps for them. So the question here is, what are the steps? Number one, select the device. Always do this. Select the device. Right. Number two, select the cable that is needed. Number three, assign the IP address. Number four, verify the connection. Right. So for this, first is this. You will be asking me why we need select the device. So what I'm going to tell you is I'm going to check both these cables using one scenario, that is peer-to-peer scenario. I'm going to build this scenario. For peer-to-peer or for any scenario, we need these steps. So for peer-to-peer scenario, what we're going to do, first select the end devices. I'm selecting one PC here, one PC here. Once we are having this PCs, what we need to do, PCs and devices basically, what we need to do, we have to select the cable. So how we should select the cable? There should be automatic cable, or there should be copper straight through, or there should be crossover. So for that I'm going to tell you a few points. Please mark these points. For straight through cable, always work with number one, in different devices. For example, PC to switch. Number two, switch to router. Number three, switch to hub. Number four, PC to hub, but not PC to router. Why? We'll tell you later. And for the crossover cable, it should be work with same devices, that is PC to PC. Number two, switch to switch. Number three, router to router. Number four, router to PC. Right. I will explain you the things later. First of all, I want to finish this. Right now, PC to PC crossover cable. So let's go and check. This is a crossover cable. Right click, take the fast Ethernet because it's a LAN cable. If you are finding green color, it means your settings are done. It is connected. Right. Number three step is assigning IP addresses. Now for assigning IP addresses, as we know that IP addresses are of 32-bit with 4 octets. Can I say 10.1.1.1 is IP address, and I have to mark the subnet mask. I'm taking the subnet mask as 255.0.0.0. And for peer-to-peer network, it is mandatory to take the PCs or devices the same network. So here I'm getting 10.2.2.2 and subnet mask to be 255.0.0.0, and it's very much clear that subnet mask is used to identify the network, right? Network ID. So this is done, assigning of IP address. Now we have to assign the IP address, but before moving to that step, I want to clear you these two steps. First thing is straight through cable. What happens in straight through cable, guys? In straight through cable, there is a architecture of 7 to 8 pins. Pin architecture is there, right? with RJ34. So what happens there is, okay, pin architecture, and pin 1 is for input of data, or we say sending of data. Just think, we are having an Ethernet LAN cable, and for pin 1 it is sending the data to one device, and on the other end pin 1, function of pin 1 is sending the data, right? When these two ends are sending the data, they collide, leads to crosstalks. So to avoid this, for same pin structure things, for same devices, crossover cable is used, right? Done. And when there are different devices, then we can use straight through cable. But if we are using this crossover devices, then what's the different point? Another point you need to add is, for straight through cable, the pin structure is same. How crossover cable is different from straight through cable? The concept of 1, 3, 2, 6 here follows, which means first pin wire cable is fixed to the third pin of other end. One end of second pin is fixed or connected to the another end of sixth pin. So this is what the crossover cable is. So let's assign the IP address to the system. Go to PC, go to desktop, IP configuration. What is the IP address? IP address is 10.1.1.1. Enter the subnet mask and it's done. Similarly here, desktop IP configuration, it's 10.2.2.2. Enter and it's done. We have assigned the IP addresses. Now verification of the connection. Go here, go to command prompt, do ping. Because I'm on the first PC, I'm going to check the second PC. Ping 10.2.2.2. Enter. You're getting the replies. This time to live, it means you are getting the replies. We can check for the second end that whether this is connected. Oh yes, it is connected also. How? We'll check it. We'll put 10.1.1.1, the ping command. We are getting the replies. How we check in the simulation? That's another question. For simulation, I'm going to select this packet, drop it here and here. Now I'm running this simulation, and wow, we are getting the GUI simulation. The package is delivered. Fine. So this is peer-to-peer network, but few points on the cables are left. Give me 5 minutes. I'm going to tell you about those things as well. Thank you. So for straight through cables, right? Let me take the brush. Okay. So for straight through cable, what we need to understand. For example, here the pin structure is 1, 2, 3, 4 and 8. You can see orange, white, orange, green, white, blue, blue, white, green, brown, brown, white and brown. Similar structure is find it here. So just think, if this is my system, right, and if this is my another device and they are connected to straight through cable, we are saying pin 1 is sending the data. Here also pin 1 is sending the data, and we know that devices with like PC, laptops, all are having the same motherboard architecture and the pin structure is same. So if they are sending data in the same direction, like this here, he is also sending from the same pin out structure, same pin structure. Pin 1 is sending data, here also pin 1 is sending data. What will they do? They will collide and there would be crosstalks. So to avoid such kind of situations, we are having crossover cables, and here we follow 1, 3, 2, 6 strategy. What does that mean? First number cables input on the one end should be connected to the third point of the other end. Similarly, third number, this green blue is not green blue, it's second number. That orange one is connected to sixth number. Second pin is connected to sixth number pin, and first pin is connected to third number pin of other side. So if this structure is there, there would be no collision and no crosstalks. That's why we use crossover cables for the same systems, right? Now the concept left for IP addresses, right? So what is that in IP addresses? IP address is of 32 bits with 4 octets, each octet of 8 bit, which means 1, 2, 3, okay, which means this dot, this dot, right? So 4 octets. Now how they are aligned? I can see 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. See, 8 bits in first octet, 8 bits in second octet, and similarly for 4 octets, 8 into 32. So IPv4, IP address version 4 is of 32 bit. So if I'm saying in the question the address is 10.1.1.1, it means 10 is in first octet, which means can I say 10 is from the back if I'll start, that is 2 raised to power, draw it, that's better. Okay, I need the brush here, pencil. So can I say if there are 8 bits, that is 1, 2, 3, 4, 5, 6, 7, 8. Can I say this is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, and 2 raised to power 7. So if I explain this means if all ones are there, if I talk about 10, and I'll explain it more, it would be 1, 2, just give me 1 second. If I explain this, that would be 128, 64, 32, 16, 8, 4, 2, and 1. If I will calculate these values, right? If I calculate these values, I will get these. Okay. If I calculate these values, I can get 128, 64, 32, 16, 8, 4, 2, and 1. Right? I will get this value, right? So if I want to calculate 10, what would be this? 8 is 1 and 2 is 1. Rest are zeros. Rest are zeros, right? Rest are zeros. Similarly for 1 and this. If I can say all ones there, 1, 1, 1, 1, 1 up to 8. So can I say that in every octet I will get 255 if all ones are there in every octet? So actually what happened is, if I'm having 255, so what happened here is, if I'm having 255.0.0.0, it means my first octet of 8 bits is fixed, rest is 0. If I can say this is here, 2 octets are fixed, it means my 16 bits are for network ID. And rest 16 bits are for host ID. Similarly, if I move further, 255.255.255.0, it means 3 octets, means 24 bits are network ID and 8 bits are host ID. Similarly for class A. So these are 3 classes. This is for class A, this is for class B, and this is for class C. In this, first octet is fixed, second octet is fixed, third octet is fixed. In class C, 3 octets, 2 octets, and 1 octet. What does that mean? That means the network address is fixed, right? And if I'm saying that I'm having 10.1.1.1 and having the subnet mask 255.0.0.0. It means my first octet is fixed, and if the two pieces are directly connected and making a peer-to-peer network, then it should be in the same network. And I can see 10.2.2.2, and the subnet mask for this should also be 255.0.0.0. Why? Because it should lie in same network. Thank you very much.